Alright, I'm back. Finishing the video 4 hours later. Here we are. What were we doing? We had this gigantic expression which was quadratic in two variables, which represented for three ordered pairs the sum of the squares of the residuals for arbitrary line y equals mx plus b for those 3 points. And it's this thing that we would like to minimize. And our goal is to find the ordered pair m and b, which indeed minimizes the sum of the squares of the residuals, so minimizes the thing in the box. And what we did was to treat b temporarily as a constant and to express this as a quadratic in M. And then we determined that any quadratic expression will have its minimum value, as we just know from an analysis of parabolas, when, in this case m, is negative the linear coefficient over 2 times the coefficient of the quadratic term. Alright, so simplifying this a little bit, we get 178 minus 30b over 2 times 83. And I can take a 2 out of the top and the bottom. So in fact I get, I guess that's 89 minus 15b over 83. Let me just double check that real quick. Yeah. Which is sort of itself kind of big ugly numbers, but I leave them for the moment. Well, now I go to the other part, which is to fix m and minimize b. I take the same quadratic expression, but now I treat m as a constant and I write it as a quadratic in b. Well, that's 3b squared plus the coefficient of the b term is 30m minus 30b plus the constants are anything with no b's in them, so that's 83m squared minus 178m plus 101. And using what we know about quadratics, again, the b will be minimum at negative that over 2 times that. And here we get something even nicer, because this top is, okay, it's 30 minus 30m, but that's over 6. And so we get that this is just 5 minus 5m. Hope this is all right. Well, here is our sort of temporary conclusion. I'm going to put a box around this, then I'm going to put a box around this. What is actually going on here is that we have written the same quadratic expression in 2 different variables in 2 different ways. Treating m as a constant, treating b as a constant, we found the minimum m, and the minimum m will be this. Treating m as a constant, we found the minimum b, and the minimum b will be this. And so, to be a little bit more kind of clear about what this actual formula is, what this is kind of, you can think of this as like a formula. What this formula says is, for any possible b, you give me a b, what this formula tells you is the m that you should pick so that our expression is as small as possible. Whereas this second thing here in this box says, okay, let's treat m as a constant, and for any possible m, this is the b which will make that expression as small as possible. And so writing this out more nicely, we get, okay, what is this? 89 minus 15b equals 83m. All right, I hesitate to call that nice, but there it is. Sort of rewriting it again, I get 83m plus 15b equals 89. Here, I get, I guess, 5m plus b equals 5. And this is a system of equations which I can now solve. And if I solve this system of equations, I hope these numbers are right, because if they're wrong, it's just a disaster. Let me multiply this bottom thing by 15. So 15b equals 89. And here we get 15 times 5 is 75 m plus 15b equals, again, 75. Alright, subtracting gives me 8m equals 14. And so m is 14/8 or 7/4. I have some vague memory of this being the right answer. Well, if m is 7/4, then b is, well, let's see, going back here, b would be just 5 minus 5m, so 5 minus 5 times 7/4, and whatever that is. This is 20 minus 35/4, so that's negative 15/4. Okay. What has just happened is I think that I've found that m should be 7/4 and b should be negative 15/4. Alright, why, or maybe what is really going on here? Here's how I like to think of it. You sort of have two axes here. You have the b axis. Let me just be careful here. Well, I guess it doesn't matter. You have the m axis and the b axis, and here is what this first box is saying is. Or maybe it's actually sort of this line here, which we're now going to sort of explore. This line here, which came from the line above, which came from this box above, was, recall, the minimum m for a given b. The minimum m for a given b. And so, the way to think about this is, you give me a b, and I'll tell you what m should be, so that this sum of the squares of the residuals is as small as possible. Okay, and here it is. It's like 89 over 83 minus 15/83 b. So it's some line, which is going to look something like this. And the way you should think about this starred box is, for any particular b, this formula outputs what the best m would be. And by best, I mean minimizing the sum of the squares of the residuals. For any possible b, this line is the line which gives you the best m. Well, okay, great. What about this second line here? Here we fixed m and minimized b. So how should I understand this line? Well, I should understand this line as saying, for any possible m, this is the best b. For any possible m, this is the best b. And so, okay, actually my graph is a little unfortunate here because it's supposed to go, this is not an accurate sort of picture of what's going on, but what now happens is you take this line, and now we are going to graph it. We're going to say, all right, for any m, I'm going to give you the best b. And so this is another line. This line is the line of all the best b's for a given m. So for any possible m, this line outputs the best b. This first line, for any possible b, outputs the best m. And since these are both lines, they will intersect at just one point. And the point where these two lines intersect is the best M for a given B and the best B for a given M. And so therefore the best overall M and B is the point that is on both of these lines. And when I solved this system of equations, that's indeed what I found. And the end result of all of this is that we have proved with algebra that the best line is the line y hat equals 7/4 x minus 15/4. And if you look back at our, oh no, we never even made a picture. This is quite sort of plausible as an answer to this. This line is best in the sense that for these three data points, this is the line which minimizes the sum of the squares of the residuals. Okay, hopefully that makes sense. Bye.